Welcome to our last day of our review for our test next week over fourth quarter. This is our last day of remote learning videos. I know you guys are excited about that, and I am too. So I miss seeing you guys in class, but you guys have been doing a great job throughout this quarter with staying up with your schoolwork, getting great grades, and asking questions when you don't understand things. So make sure you are doing the same thing as we're preparing for this test next week. Don't forget, either today, May 15th, or Monday, May 18th, go ahead and call me via Skype just using my school email address between 9 and noon. That way I can give you credit for having completed this work packet with me. So don't forget to make that call either on Friday or on Monday. So let's pick up with our last set of questions for today, beginning with question 25. Here's question 25. We have the problem 10 to the negative 2x plus 2 is equal to 8. This was one of the last lessons that we covered in the last week or so of school, where we talked about our exponential equations. The exponential equation is where we had our x up in the exponent. Well, how did we get the x out of the exponent? We took what was called the logarithm of both sides of the question. Now, there was two kind of logarithms that we had. One was just our log, that was called the common logarithm, and then the other one was ln, the natural logarithm. How did you know which one to use on a certain question? It was determined on the base. Well, I see that there is a base of 10 on this question, and that's the one that corresponded with our log. That was a logarithm that had an understood base of 10 in the question. Now again, why did we want to put a logarithm on both sides of the question? Is anytime I had a logarithm that had the exponent, we could shift that exponent down to the front. So I have negative 2x plus 2, and I kept that inside parentheses because there was two different terms there, and then log 10 equals log 8. Now, what's very, very helpful about this question is the fact that on the left-hand side, I see log 10, and I know that log 10 is equal to 1. Why did we know that that was the case? Well, what base is understood to be there on that logarithm? Let me go ahead and pull up my pen here. So what base is sitting right here when it just has a log? That's an understood base of 10. Well, remember our White House questions? When the base of the logarithm matched the base of the exponent, your answer was just the exponent. Well, 10 is the same thing as 10 to what power? It's 10 to the first. So these two bases kind of cancel each other out, and there's that number 1 that you're left with in the question. Why is that helpful? That means this part of the question right here where it says log 10 is equal to 1, well, times 1 doesn't do anything, so the left side of the question is just negative 2x plus 2, and now that's still equal to log 8. We can continue to solve for x at this point of the question. The first thing I'm going to do is subtract 2. Now remember, you can't subtract the 8 and the 2 because the 8's next to the logarithm and that 2 is not. So we've got to write them side by side like I did up here on the screen. One last thing to do to get the x by itself, divide by negative 2, and I would have log 8 minus 2 all over negative 2. At that point, go ahead and type that on the calculator, and that gave me, when I rounded it, that x was 0.55. If you're adventurous, you can, of course, go ahead and check that. Put your 0.55 back in the question. Negative 2 times 0.55, and then add 2, and then 10 to whatever that exponent is should give you something pretty close to 8. It might be 7.99 something or 8.01, but again, it's going to be very close to the number 8 that we have in our question. One more exponential question to walk through. We have 5 to the 2x minus 1 equals 6 to the x minus 2. Now on this question, unlike what we just did on number 25, we do not have one of our special bases, either the 10, which told us to use our log, the common logarithm, or the base of e, which was our natural logarithm. So it's really our choice. Whichever one we prefer is what I can do on this question. I just stayed with the same logarithm. I stayed with the log, but you should get the same answer at the end if you did the ln. Why do I want to put the logarithm on both sides of the question? Just like back on 25, it allows us to shift the exponents down to the front. Again, I use parentheses because both of those exponents have two different terms. So parenthesis 2x minus 1, and then log 5 equals parenthesis x minus 2 log 6. I can't ignore anything this time like the last question because the bases do not match with the log 5 or with the log 6. So how do I proceed to solve at this point of the question? We're going to have to get rid of those parentheses, so we're going to distribute. On the left-hand side, if I distribute log 5 in, That gave me 2x log 5 minus 1 log 5, or just log 5, equals, then on the right-hand side, when I distribute log 6 in, I have x log 6 minus 2 log 6. Well, don't forget, the goal of the question is to solve, which means you need to figure out what the x is on the question. The x's are currently on different sides, so let's go ahead and put them together. I took the x that was on the right-hand side and moved it to the left-hand side. How do I move the x log 6? Well, I would subtract it. Now, when I subtract it over, those two are not like terms because the one already there has a log 5 and the one I'm bringing over has a log 6. So the left-hand side, there's the 2x log 5 that was there originally, and there's the minus x log 6 that I brought over from the right-hand side. Now, at the same time in the question, I took care of the minus log 5 that was on the left side. I moved it over to the right-hand side of the question. To do that, I would add it over, and just like I explained during class, I personally like to put the positive one first, so I put the positive log 5 that I just moved over, and then there's the minus 2 log 6 that was there already on the right-hand side of the question. Back to the left-hand side of the question, because that's where the x is that I'm attempting to solve for, but it's in both of those terms. What do we do when what we're solving for is in two different terms? We factor it out to the front. So I have x times 2 log 5 minus log 6 equals, and then the right side is still the same, our log 5 minus 2 log 6. Next step, to continue getting x by itself, I need to get rid of that multiplication. So I'm going to take the right-hand side divided by the left-hand side. So my x is log 5 minus 2 log 6 all over 2 log 5 minus log 6. So hopefully during this lesson last week from lesson 82, I believe it was, you were able to kind of figure out on your calculator how you would need to enter this kind of question. And when I did that, I came up with that x was negative 1.38. Again, if you're having issues, you can't type that in, or you're not getting the right answer, then please let me know so I can explain to you what buttons you need to press and then in which order so you can get that correct final answer. All right, we're ready for our last section that we have coming up on our review packet here. And this is where we talked about how to write our equations for our sine and our cosine graphs. Questions 27 and 28 are both in the directions asking us to do it as a sine graph, and then 29 and 30 are going to be asking for a cosine graph. So you have the pictures on your paper. I don't have them up here on my slide, so I just wrote the page number where I found the picture from. So you don't have to turn there unless you really, really wanted to, because you have the picture in front of you. Well, notice as well on your paper, right above the picture on question 27, you see the format that you should be using to write our sine graph. It says y equals dotted line. So let's go ahead and take a look at the graph that you see there on question 27. What is the dotted line that we see on this picture? It is a negative 1. So I started my equation. Don't forget the y equals, because this is an equation. Y equals negative 1, and then that was always a plus sign that we put next, and you can see the same thing is true in your formula. The amplitude comes next, and that's your height from the dotted line, either going up or going down. So if I went from negative 1 up to 7, how many spaces did I move? 8. The same thing would be true going from negative 1 down to negative 9. The distance again is 8. We're putting our sine next because we're in the directions we're supposed to write our sine graph. The next thing that we need to put into our equation is the period. Remember, the period was the rotation, so how fast is this graph rotating at? What was the normal rotation that we had on these kind of graphs? It was 360 degrees. So what we had to do on these questions was take our 360 and then divide by the new rotation that I have on the picture. Well, how do I find the new rotation? I need to find two places on the picture where I see the exact same thing happening. So if I look at my picture here, I notice at negative 90 as well as positive 90, the graph has reached two tops of the hills. Well, how far is it from negative 90 all the way over to positive 90? It is 180. So I'm going to do 360 divided by 180. Now, that wasn't the only place I could go to get that information. Notice in the graph, it's headed down at negative 45. It's also headed down at 135. The distance from negative 45 over to positive 135 is still 180. So as long as I find two places that are close to each other that have the same information, whether it's the top of a hill, the bottom of the hill, it's headed down through the dotted line, up through the dotted line, then it's going to be okay in the problem. 360 divided by 180 is 2, and that's where I got this coefficient for the period that I have in the question. The first thing that I'm always going to put inside of our parentheses is the theta, because that's where I'm going to represent the phase angle for how did this graph shift, either to the right or to the left. Well, what was I looking for when it came to a sine graph? We were looking for the point closest to the origin where it was heading up through the dotted line. Well, again, if I look at my picture, where is the graph headed up through the dotted line? It's at 45 degrees. But we're putting this information inside parentheses, and things inside parentheses are the opposite. So I have theta minus 45 degrees for my final answer on question 27. Let's look at our graph that we have here on question 28. Again, we're writing this as a sine graph. The first thing that we need is the dotted line. So what do we notice is the dotted line on this question, it is a -3. So it wasn't in the picture originally, but I do have it there on the graph for you. So I have -3 plus. What is the amplitude? What is my distance from -3 up to 7? It is 10. Again, the same thing from -3 down to -13. We're doing our sine graph again. So how did I come up with the 3? I started off with my 360, which is my normal rotation, and I'm dividing by the new rotation that I have in the picture. I notice in my graph here, it's heading down at -40. It's also heading down at 80. How far is it from -40 to 80? It is 120. So 360 divided by 120, that's where I got my coefficient of 3. Again, what are we looking for the angle for our sine graph? It's the angle closest to the origin where it's headed up through the dotted line. And I noticed that was happening at 20. So inside my parentheses, I have theta minus 20 degrees because I had to put the opposite inside of our parentheses. All right, 2 more graphs to walk through. Now notice we're switching to cosine as we're writing these 2 equations down. Same rough format, we're just going to switch out the cosine, and then we'll look at how did I determine the angle at the end for a cosine graph. So again, we're going to put down the dotted line first. The dotted line that we have on this question is +3. How far is it from 3 up to 8? It is 5. So I have 3 plus 5, and there's my cosine since we're doing a cosine graph. Where did I get that 1/2 for the period? Again, we're always starting with 360 degrees because that's my normal rotation, and then dividing by the new rotation that I have in the picture. In my picture, I'm deciding that I'm going to use -450, that's the top of a hill, and I'm also going to use 270, that's the top of a hill. How far is it from -450 over to 270? That is 720 degrees. So I have 360 divided by 720, and that reduces down to 1/2. So that's where I have my fraction in front of my parentheses. Now, how did we determine the phase angle when it came for a cosine graph? We were again looking for the angle closest to the origin, but this one had to be the highest hill that we have in our picture. The angle that meets that requirement is 270. So again, I'm putting the opposite, theta minus 270. All right, last question. Let's go ahead and take a look at this graph with regard to our cosine. Again, same rough setup. Our dotted line comes first. The dotted line that we have on this question is -3. How far is it from -3 up to 5? It is 8. So I have -3 plus 8, and there's my cosine. Let's look at where does that 1/4 come from. Again, we're starting with 360 degrees, and then we're going to divide by the new rotation that we have on this picture. Our rotation, I'm deciding to use -540, which is the bottom of a hill, and 900, which is also the bottom of a hill. How far is it from -540 over to 900? That is 1,440. So I went ahead and reduced that fraction on my calculator. 360 divided by, divided by 1,440. That turned into the 1/4 that I have on the question. Again, what are we doing for a cosine for our phase angle? We are looking for the point closest to the origin where it's at the highest hill. I noticed the highest hill there is at 180, so I put theta minus 180 degrees. So that wraps up our review. Again, if you have questions on any of these problems from numbers 1 through 30, something we did that you didn't quite understand, please go ahead and contact me so that way you can do well on the test next week. Don't forget, you do need to contact me anyway because you'll need to show me over Skype either today, May 15th, or Monday, May 18th, your completed work packet. So don't forget to do that so I can give you your grade for doing this work with me.